Hello everybody, I'm Captain MAMGAIN. Last we had talked about finding out a latitude by lower meridian altitude, circumpolar bodies. So let us just put that knowledge into practical use, though um, uh, practically speaking, you do not get the latitude by meridian altitude because you're always on the move. Somebody has to be stationary uh, to observe the same body on the meridian below, and our HCV always moving, and could be possible if you're moving along up the latitude and the declination of the body remains constant. But anyway, it's important for us to know understand this from the examination point of view. Now, this is an extract from the almanac, and question is like, are these bodies circumpolar, and what is the reason for these bodies to be circumpolar? It can be put any way to you. Here I've got two stars here, Canopus and Dubai. The declination, one is south, one is north, and we uh, saw that the condition for circumpolar bodies, the latitude and declination have to be same name. So once you know the declination, definitely the latitude also has got to be the same name, south here and north here. And the second condition when we talked about was the latitude plus declination should be greater than or equal to 90. So for these two stars to be circumpolar, for Canopus, the latitude has to be equal to or greater than 37, and in this case, 28 and above. Now this is a figure on observer's rational horizon, and here on the observer's meridian, I have put the observer as north, as you can see it, north of the equator here, north of the equator here. Now circumpolar bodies are the ones which are visible at the lower meridian and which do not set, and latitude and declination have to have the same name. So here, latitude, declination, same name, north. Now, if you notice here that the body is on the observer's meridian, on lower meridian, the azimuth in the northern hemisphere is north, as you can see, north from here, north. So when you have a question like this, invariably, if azimuth is given to you as for the lower meridian passage, so you straight away come to know that the declination and azimuth should be north. So 50% of your question is done as soon as if you realize this part of it, that the azimuth or lower meridian passage in the north will be north, in the southern hemisphere it will be the lower meridian passage will be south. As you can see, if I am in the northern hemisphere, I can see the south because from Q to the south pole would be 90, which is below the rational horizon, which you can see here. But this is my pole, that's my north. This is my south. I'm below the rational horizon, so I will not be able to see it. So anything which is circumpolar on the southern pole will not be visible to an observer on the northern hemisphere. As I said, that 50% of your question is solved here. That your azimuth has already decided what should be your latitude and declination. Now this question here, north, bearing north. So latitude, declination has to be north. And you notice that always your lower meridian passage is smaller than the latitude above the pole. Southern latitude, equinoctial, southern latitude here. Now, as I said, this north pole is not visible, so anything which is circumpolar here will not be visible to a body, to an observer who is on the southern hemisphere. So if the azimuth is given to me, here, if I can see this I'm the observer here, and the body is bearing south. Yeah, observe bearing south on the lower meridian. So latitude and declination is south. So as I said, all your questions, as soon as you come to know what is your lower meridian passage azimuth, your 50% of your question is solved there. Now, this is your body, celestial body from Q to X. We know that that is your declination, and being south of the equinoctial, south declination. P to Q is 90, that's pole to equinoctial. And what is PQ equal to? Is Q to X plus PX, and QX is your declination. So declination plus PX is 90. So how much is PX? PX is 90 minus declination. Now body is circumpolar. You are able to see it on either meridian, upper and lower meridian. Body does not set, and the body is making a circular path along with pole as the center and with along the declination circle here. P is the if the P is the center, that means P to X is your radius. P to X that is your radius. So Px, we just saw this 90 minus declination, so Px dash should also be 90 minus declination. And we learned earlier that from south of the rational horizon to the pole, that's the altitude of the elevated pole, that is your latitude. Now if I know the latitude above the pole and the latitude below the pole, I can always get the diameter of the circle. So you subtract one from the other, you get the diameter of the circle. And that is equal to how much? It's 2 times this, isn't it? So if I had to find out my latitude when the declination was given to me, so I can use this to find out my latitude. That's my altitude minus my 90 minus declination here. And similarly, I knew the altitude below the pole and altitude below the pole plus 90 minus declination. So if I know the latitude, I can find out my declination. If I know the declination, I can find out my latitude. If I know the altitude, I can find out both of them. So it's quite simple basically. Now this is a question here, as I said, it's given me above the pole north, below the pole north. As I said, looking at this question, yes, now I know that my latitude is north and declination is also north. So just to go ahead with solving the problems here, I have drawn the thing here, already taken into account that this is north, so I put the observer north, and this also I put the observer north. Now the meridian of an observer, as we had talked earlier also, was PZQS. Observer is here, the observer meridian will be PZQ, P dash here, and P to N is the one which is below the pole, so lower meridian. Similarly here, observer's meridian, this side is your observer's inferior meridian or observer's lower meridian. And Z to Q is the latitude. Q to Z is the latitude, Q to Z is the latitude. In this case, he is giving me above the pole 57. So above the pole, altitude is 57. And it is north, so that's why I put it here. I did not put it on this side. Again, below the pole, north, azimuth north, I put it here. And circumpolar body is describing a circular path along its declination circle here. So Q to X is your declination and to P is your latitude. Px is 90 minus declination, and that is equal to Px dash also. Now, one latitude minus the other latitude, I get the diameter of this circle, x6 dash, as you can see it here also. One latitude, the second latitude, I get the diameter of the circle here. Now, x6 dash and x6 dash is half. Is x6 dash is 2 times 90 minus declination here. And if I just wanted px or x dash, I'll divide it by 2. And now knowing the altitudes, I can always find out my declination or the latitude. Once I know my lower altitude, 90 minus, add 90 minus uh, above the pole. If you just subtract 90 minus, you get your latitude. Now this question I've just divided into actually 2-3 different parts. So looking at it, I straight away know that the lower transit is north and upper transit is south, so the latitude should be north and south, but I have not purposely put it up here just to make you understand the figure. So I've just broken this question into 2-3 parts here. They said that by looking at it, of course, I already know the answers here, what should be my latitude and my declination. This is the diagram on observer's meridian. I've just taken this, the observer on the south latitude. Though I know that the answer was north, but just to explain it to you, I've just put it on the south. And 90 degrees to the azimuth is your rational horizon. This is the meridian passing through the observer. I'm not talking about the upper or lower meridian here. And this is the meridian through the observer here, and that's of course the lower meridian or inferior meridian here. Now he said that on upper transit it is bearing south. I put it here, bearing south. Again, bearing south, altitude from rational horizon to the body. Rational horizon to the body, 80 degrees, perfect. He says the lower transit is 11 degrees, 5 minutes north. Here, good, it's going on, correct, it's still north, get it here. Now in this diagram, north is here. If I put 11 degrees 45 minutes from the rational horizon 45, then my azimuth would be north. Once I put it here, it is bearing south. It is on my observer's meridian. It is on my inferior meridian. Whereas here it was still on my meridian. So two things were contradictory here. One was that it was still on my meridian and it was not bearing. It was not. It was bearing north, all right, but it was on my meridian. Whereas here, when I put it on my inferior meridian, it is bearing south. So this placement of my observer is wrong here. So I'm just putting the observer back into the north side here. Now if you look at it here, bearing south, upper transit, this is my meridian, and it bearing north when it's on my lower meridian. My lower meridian is P and QP dash. So now observer is definitely in the north hemisphere, as we had said that you can understand it right from here. This diagram was just to make you understand. Of course, these diagrams are more easy to solve these questions. And then, as we said, that the circumpolar body goes round the pole as the center along its declination circle. P to Q is 90, Z to S is 90. So Q cannot be on this side anyway. The equinoctial cannot be here because from Z to N is 90. So P to N is definitely less than 90. So Q should be somewhere here, which is going to be outside my rational horizon, so I will not be able to see the equinoctial. So equinoctial should be here, and my latitude would be north. Q to X is my declination, and P to X is 90 minus declination. 90 minus declination. Now N to S is 180. N to S is 180. If I had to find out X dash, so 180 minus this, that's the two altitudes. Then I would have X here. Same here, this is 180. 180 minus Sx, Nx, I would get Xx dash. And I get my Xx dash as 8806. And we know that P is the center. So half of this would be Px, half of it would be Px dash. So I got 4408. And that is 90 minus declination is equal to 90 minus declination, right? 90 minus declination. So equating these two, I can get my declination. And using the declination, I can always find out my latitude. Now the last part of the question is talking about the calculate the true altitude when on prime vertical. When we are talking about vertical circles and GHA, LHA and other things, I've spoken to you about all the circles also. The prime vertical is a great circle which passes through east and west of the zenith. So here east and west is passing east and west, so definitely it will be making an angle of 90 degrees here at the zenith. So angle here it is 90. Now he wants me to find out the altitude of the body when it is on the prime vertical. So altitude is from rational horizon to the body. So he wants me to find out Xc from my rational horizon to the body. And we know that the declination is what is the arc of the meridian. It's a great circle, semi-great circle. So, and from equator to the body, that's the declination. From equator to the body, arc of a meridian, which is semi-great circle. So, from equator to pole is 90, so px dash would be 90 minus declination. So 90 minus declination here. And from Q to P is 90, Z to Q is latitude, PZ would be 90 minus latitude, 90 minus latitude. Now, this triangle, what is that? PZX. PZX is a right angled spherical triangle because one of the constituents of the triangle is 90, which is angle here is 90, and the other three sides are all great circles. So it becomes a spherical triangle with angle Z as 90. Now, I had spoken to you about how to go about solving these right angle triangles and by using Napier's rules when I was discussing about great circles. So I'll not go into details of how to go about using that. I'll get on to the point here, and I am to find out ZE, ZE. So I should basically in this triangle I should find out ZX dash. So using the formula for Napier's rule, I calculate ZX dash, and ZX dash is Senate distance, which is 90 minus altitude. So I can find out my altitude, 90 minus Zx, and that is my altitude, and the body will be on the prime vertical. I says find the two latitudes in the star declination bearing 180 degrees. Altitude given to you. Now there are two possibilities: either the latitude is north or latitude is south. We talked actually about three possibilities. The third one I'm not discussing here. So it is either latitude is north or latitude is south. Declination south. Declination south. Now altitude is given to me is 11 degrees. Good enough. So I can always find out my latitude here. I get my Zx, which is my zenith distance, 90 minus altitude, and zenith distance minus my declination, I get my latitude. Now we look at this case here when it is south latitude, south declination. We get Px as 21 degrees 09, and the altitude of this body is being given to me as 11. So it is definitely not here because from here to here is 21, so it has got to be more than 21 here, right? And being the declination south, the body cannot be here anyway. So this is not possible. So that definitely that means I am seeing the body on my lower meridian. So the body becomes circumpolar for me. Now I have altitude, which is okay with 11 degrees 05. I have my px dash, which was we had found out as 90 minus the declination, and my latitude south. Now this is a diagram on observer's meridian, and assuming that the observer is on the equinoctial latitude 000, rational horizon would be 90 degrees to it. This is on the observer's rational horizon, Z, all points 90 degrees. He says the observer is on the North Pole. Here, of course, the observer is here. Now, just considering that the observer is in the North Pole, so let us move this observer to the pole, North Pole here. Now, you see what is happening when I'm moving around. Rational horizon moved along with it, and it is coinciding with the equinoctial. Similarly, if you look in this figure now here, the pole, when we are making it on rational horizon, pole will be here. Once I make the pole here, equinoctial will keep on moving down, and the equinoctial being a great circle will coincide with the rational horizon. In this question, the thing is, he's given me the true altitude of moon when on the north pole is 19 degrees 10 minutes. Altitude is measured from rational horizon to the body altitude, and how what is the arc above the equinoctial is the declination. So in this case, the declination and the latitude is one and the same thing here. Now, here again, if you're measuring it with rational horizon, the distance off from the rational horizon, you'll have the altitude. If you're measuring it off the equinoctial, it is your declination. Now, with the rational horizon, the arc of the meridian is your altitude. And if you're talking about the arc of the meridian, measuring it from the equinoctial would be your declination. So now in this question, that means your declination is 19 degrees 10 minutes, and being north of the equinoctial, declination would be north. And he wants me to find out the latitude in which the altitude would be double this. Altitude should be 3820. As I told you earlier, there are two possibilities. It is either north latitude or south latitude. So here I am just showing you with latitude north, declination also north. My figures are not to the scale. These are only for making you understand, because the altitude doesn't look like 38 here. So don't go by my diagrams. This is only for making you understand. So altitude is from equinoctial, from rational horizon to body, 38 degrees. Declination is 19 north. I can always get my zenith distance, add my declination, and get my latitude. The other case, what I told you about, is that they are opposite. South latitude, north declination. Now again, NX 38 degrees. So I can always get my zenith distance 90 minus altitude and subtract my declination to get my latitude. As I said, my figures are not to the scale, only for understanding part of it. Now these are few questions what I just came across, so that you can understand how much you've understood on this topic. And I've just given you some hints here with the answers. Most likely everybody should be able to manage them. In case there is anything, I'll think about loading up these answers also a bit later. Till then, you can just go through these questions. Thank you very much. We'll continue.